I'm Nikhil, front-end developer. I currently work at Cloudera. I mostly work on React and I use TypeScript for as a language. If you have types, let's say if you're using a package from a different library and then it has type safety built into it, then you can in your VS Code or any other editor, you'll have that autocomplete. In Java, there are multiple types. For example, string, number, object, arrays, and all those are types. So you can define those in TypeScript. For example, testing a variable is a string or so without this return type, this is a TypeScript one. Without this, it's not TypeScript. It's just JavaScript. Since it's avatar component, think of it as so either the avatar, your image can come from an icon or from an URL source. So for that, we are using this. So there are specific uses for it. But what generic is, once you define a type, when you call it, you can call it with multiple types. It's like a function. I'm defining state as anything, but the initial should be a type of states. I mean, key of states. So my state can be anything, but it would be the initial would be a key of whatever I give here, A, B, or C. If you plus D, it won't throw it. It will throw an error. It can be only A, B, and C. So this is another powerful example for generics. So first, let me introduce myself. I'm Nikhil, front-end developer. I currently work at Cloudera. I mostly work on React and I use TypeScript for the language. So how many of you have used TypeScript before? Can you get that right? Okay. Yeah. So first question is, why did you choose TypeScript over JavaScript? Any one reason? Main reason to go for TypeScript?
Scale.
Type safety. Okay. Any particular use case?
Because JS likes types.
Yeah.
Checking, so better to add TypeScript.
Exactly. So any particular use case that
it will come on when I write my code itself, I know there is an error happens in my code, so I can be foolproof that my code will run better in production or maybe before when I develop itself, I know that the fact that I'm writing code that actually is more strictly typed.
Mostly error prone also, you can easily check for errors. Yeah. Any other reasons?
Pretty much to avoid the errors in production.
Yeah.
See errors.
So that's also one of my main reason to use TypeScript. One other reason is autocomplete. So even if you have types, let's say if you're using a package from a different library and then it has type safety built into it, then you can in your VS Code or any other editor, you'll have that autocomplete. For example, let's say React component library, let's say and design and material UI. When you import the component, you can just see if you tap command control space, you can see what are the props that this component takes and what is the type of those props and all those things. That's one of my main reason to use that. So easy to use. You don't have to read documentation that much for every single prop that you want to use. And another thing is refactoring. So if you want to change a function, let's say I want to refactor that function. If I have used the function in multiple other pages, multiple other files, the main reason is if you change the function parameters or return type, those places will throw errors, and which makes sense to go and change the implementation or calling of those functions. So these are the main two reasons I use TypeScript. And so before a couple of months, I've been using TypeScript very trivially, just for the props, just for the function return types, just for those trivial things. But I had to develop some component library in my company. So while doing that, I found that there are many features in TypeScript that are very underused. It's really powerful and very easy to use as well, but it is mostly underused. For example, generics, typecast, and all those things. So that's what this talk is, to explore those advanced TypeScript concepts with an easy to understand example that we can use in your project next time. So for those of you who are new, I'll just introduce what is TypeScript first and get to the examples next. So in JavaScript, there are multiple types. For example, string, number, object, arrays, and all those are types. So you can define those in TypeScript. So you can define types in two ways. Okay, before you even define types, if you just use const, let's say name equal to name. So if you do this, export something first. So this is just, if it's a file, I have to export something. That's the error throwing. But we see I just defined this is normal JavaScript. I didn't define any types here, but even if because the file name is TS, the type is inferred here. Okay, so it is inferred as Nikhil, but this is a string. It is inferred as Nikhil. This is because this is called as literal types. So since it's a constant, it won't change anything. What it means is the variable is contained has the name literal itself. So it is not a string, just a literal. So if I do a lit, right, now it's a string because it can change. The name can be changed to anything else. So now the overall type is string. That's what the name variable gets. But if it is const, since it won't change, it got the literal itself because it can't change. The only name is literal. It can be anything. So let's say a number. Now it literal be 20. Same thing if you do let. Now this will be a number. The overall type will be taken off. And we can also do objects here. Let's say name. This is a user. Name Nikhil. Okay. Now this will be name is string and age is number. If you do const, still it will be name, string and number. So because object can be, it's not immutable, object is mutable. So even if it is const, you can change the user dot age to, you can still do that because objects are mutable, properties are mutable. So you can't change the user itself. You can't define user equal to something else. This will be error because const cannot be done, but the property inside an object can be mutable. So to avoid this, what you can do is you can do const as const. This is a TypeScript thing. So far you have seen nothing is TypeScript, everything is JavaScript. Since it's a TypeScript file, all the types are being inferred from here. This is a TypeScript keyword as const. Now what will do is the properties are read only here. See, read only. Now only you can read those properties. We can't change it. So user dot age, okay, you can't do it. It will throw an error. Saying age is read only property, you can't modify it. So this is inferred type. So TypeScript is smart enough to infer what the value is from the initialization itself. So what if you want to just declare it, and in the future down the line you want to assign the values. So for this, what you can do is let's say the name would be string. So if we don't give this just name, which is normal JavaScript, what we'll do is the type will be any. So it can be anything. It can be string, it can be a number, anything. But you know this would be a string. Down the line, you will be using this variable as a string only. Then you can do this. Now the type will be string. And you can set the value. So assign the value to it at any point in the program. This will work. But you can't change it to a number. No, this will throw it because you declare it as string, but you're assigning a number to it. So this will throw it. So this is really useful. So this is a basic thing that TypeScript is useful for. You just restrict your variable to a particular type so that it's not misused or it not by mistake it can't be assigned to anything else. Let's say let's say names. This variable in your program can be a single string or array of strings. So it can have both values. That's the concept for this variable. So for that, what you will do is you will do a string and use the pipe operator and then string array. So now this variable can hold a string or array of strings, both. So it can hold a single string. This will work, and it can also hold an array of strings. But you can't hold anything else. You can't hold variable 10, will throw an error. You can't hold array of variable numbers, will throw an error. Saying number is not assignable to string. So this is how you can define multiple types of a particular variable. So TypeScript is extensible. So it's not like you're very much restricted to it. You can add any multiple values to it, multiple types to a single variable also. And so in most cases, you won't use primitive types. You want to define your own type to the variable. For example, we saw user, right? User has name, and age. So what if this type is reused in multiple other places in your program? So you want this to be a type itself. So basically you want to have a user defined type, like a string. So string is a keyword that you can use anywhere in your program as a type. But you want this user to be a type similar to string. So what you'll do is you'll use the type keyword. Type, let's say user. This is just your basically a convention where you for all the types you use capital letter at the front, equal to name. So this user is of this structure. So name would be a string and age would be a number. So now you don't have to define this initially. Similar to how we define a string variable, you can define a user variable. So now this user variable is of type user. So now you can assign a value to it. And this is the autocomplete that we're talking about. So let's say this user is from a different library or anything. You don't know the structure of this user variable. You can press Control and space here to get the autocomplete and then see what is the available values for it. So it can have the two properties, age and name. Those are the only two is available. And if you press this, you can see what is the property type also. The age is number and the name is string. So you get these autocompletes from it. So it's easy to use as well. So if this user is defined in some other file or you have defined it some other file and you're using it in this file, so you don't have to go to that file and see what are the available type properties to this user. You can use it from and so this is about type. And you can also, there's another way to define type is using interface. So interface user equal to won't be there. You can just have this. This both are same. The only difference here is the usage of it. So with types you can define. So with interface you can only define object properties. So you can only define these curly bracket, basically objects. So you can't define a single primitive variable to it. For example, I want let's say. So these are names, right? Names to be string or string array. I want this. So and let's say names to be names type. So it is either string or string array. So you can't do this with interface. You can use type only. So with types you can do objects as well as this single primitive variables also, primitive types also. But in the interface you can only do the object types. So it's interchangeable based on your requirement. You can use either. So this is just the basics of it. So let's get into the first advanced example. So any doubts in the so far? We want to cover anything else? So we want.
I'm getting a list of JSONs. Okay. So I'm doing some function and I run by loop. I'm assigning some very values to this user.
Yeah.
In case the age was, we have declared as age as a number. But might be it is the different kind of text, might be the string or somewhere. So in this case, how you are handling?
So all the types are only for the compile time only. So in the runtime, if your program is getting if you're looping the list of users from let's say from some API response that you don't know what exactly it is, then you won't have any errors because everything works in compile time only. TypeScript works in compile time only. So if you define those properties that you will get from the JSON, for example, user, this is what the user is, and from JSON get users, list of users, and this would be user array. This is how you define arrays. So this will be user arrays. So now this would so let's say name Nikhil and age 20. So similar to this, I have 3-4 users here. 4 users here. So if you have this initialization in your code, then if you loop through it, you'll get those autocompletes. If your this is your JSON structure, if it is same as in your backend, then you won't get any errors. But if it's age is string in your backend response and you get from it, it won't throw any error because it's only calculator or the types are only detected in the compile time. So you won't get any errors. If you don't do the errors properly, your application will crash because of mismatch of types. But it won't throw any error in your compile time, so you can't find those things. So as a developer, you have to make sure your response structure from your backend and the front end are typed properly. So to avoid those, that's the only thing. But if you want to throw runtime errors without crashing your application, there is something called as ZOR. So TypeScript first schema validation. So this is mainly for the API responses. So for all so what you can do is TypeScript first schema validation with static typing. So even this would throw error in your runtime, but it won't crash your application. If you handle the error properly, it won't break your application. But TypeScript without ZOR is just in the compile time only. So if you have the initialization, everything is correctly done, and your code aligns with the data types that you define, and it is same as what you have in your backend, then there won't be any issues. That maintenance between the front end structure and the backend should be nice.
And the values might be different. For example, the values getting from the content management system. So as a without technology person, they can provide some other different kind of inputs, right? So in that perspective, so the values might be actually differently. So in this case, it definitely will be might be the problem.
Yeah. So if the data changes, then even maybe in the response itself, there should be an option to convert it. Let's say, so we have this number or all those things, right? We can convert this string to a number like this. If you think user might be some made mistake of giving us just a string, we can do this conversion before assigning to the variable. So now this way it won't fail. So if you think that those things can happen, the change type can be changed, then you have to use the normal JavaScript whatever you use to convert those types to a different type. Then you have to use that. But for checking, for throwing the runtime errors, you can use ZOR. This is really useful. So let's move on to the first example, type guards. So this is a typical example that you use. For example, testing a variable is a string or not. So without this return type, this is a TypeScript one. Without this, it's not TypeScript, it's just JavaScript. So this returns, if type, this checks for the variable that is being passed, type of test is string or not. So since it's an equality operator, it returns Boolean. So now if I do, for example, if I call this function with this variable, and if it is a string, then I'm using the string property. I'm console logging the string property, length of the string. So now if you see in TypeScript perspective, not in the runtime, forget about the runtime, just think about the code evaluation in the compile time. So now if you see it returns true, then even when it returns true, it's a string, the type is any here. So you won't get this autocomplete. Dot what you don't know because anything can be there. So this property, this can be object, it can be number, anything can be. So you won't get the autocomplete for this. So to get these things, since we know this will be true in runtime, this check will be true in runtime. You have to get that property variable in the compile time itself. So for that, you will do this. You will say this parameter is string. This is the keyword here. So whatever you are checking here, you can put this. For example, if you are checking for number, put number here. Or if you're checking for some another type, user type or user defined type, you can put that type as well. So what this does is, this is like an assertion, compile time assertion. So now what we'll do is return type is not Boolean anymore. It is test is string itself. Now what you'll get is, since after this function is being passed, now you will get the type as string. You won't get it as any. So now we'll get all the autocomplete here. All the string properties will get here. So in the compile time itself, so we're not running this program. It's compile time. You are having it in the in your editor itself. Even here, you get the function being called, and you are getting the types correctly typed here. So that is a usefulness of is keyword. So you are asserting after this function is being called, it would return string if it is a string. So now, okay, if it is true, then you will get the type assigned to it as well. So this is a useful thing. But this only works in compile time. So what if you want to throw error in runtime also? So and for this, what you'll do is you are just checking for type here, and wherever you are using this function, you have to use this if statement. So if it would be a it would be a string, and then inside this block it would be a string. So if, for example, if it's an else block here, and this foo would be any. So only inside this if block, this would be a string, because only inside this if block only it is passed the string. So it will be false outside of it. So it will be any. So every time you have to use it, use the string function, you have to use the if statement block. So, and to avoid that, and also to throw the error in runtime, you'll use the asserts keyword. Same thing, test this string is the same. So this test can be anything. It's just a variable parameter name I have given. This string is the main thing, and I'm adding asserts here. Now what it does is you will have the if statement here itself, and then throw the error as it's not a string or something, and you'll check for if it's not a string. So here we check for string, and we returned you have the if statement here, and then while you're calling this, you will have the if statement everywhere. Now here we have the if statement here itself, and then we are throwing the error. So now what it does is you can just call this function with any variable, it can be any of any type. Now after this, in your code block, this would be string. Because if it's not a string, it will throw an error, your application will stop, and it won't come to this point. So when it comes to this point, then it would definitely be a string. So you don't have to use the if statement anywhere else in your code, only in the function that you define.
So the first example, so that is the string. So to work the test is a string, the return time should always be a boolean.
It depends. So not necessarily, it can be anything. So since it's just a check that we're doing, I'm just mentioning the string and the variable, but it can be anything. This example has, so in this example, I'm testing for string. So it is this string. So so let's say it returns 25. It doesn't matter.
So how does this work with the if and else? That's what I couldn't understand. So the return is something else, like let's say number or something like that. So how does it work with the if?
Yeah. So yeah, right, you're right. So is return, yeah, exactly. So this would be a boolean only.
Boolean.
Yeah, this would be boolean, and here it doesn't have to be return type. It's void. It doesn't have to return anything. So if it throws an error, it can throw an error. If it passes, it won't return anything. So this would be void, but it won't say void because we have the assert function here. So, but this without the asserts, if this is an is, if it is, then it will return a boolean value. So it checks for a particular type here. It doesn't have to be type also. For example, if it's a user here, user, let's say user type is admin. You can check for that also. Say if you're passing in user, it's a user. Maybe I think I have to have an admin user. I think it also only works for primitive types. I think I haven't tested with the predefined. Okay,
Small user and capital.
We define the user class. Say the name, string, and type. Maybe admin or types. So this would be so this can be we can test for. So instead of type of, I can test for user dot type admin dot monitor. So it doesn't have to be a type of or anything. Just it has to be a boolean, and this can be use admin. So if you do this, then what you will get is this type definite. Okay, so I think I have to do specific. So since I have defined the admin user itself, it has the type as admin or non-admin. So what you can do is maybe type admin user. This maybe this will be interface. So this extends user. So user will have, let's say user is having only the name property here, and there are two interfaces. One is admin user and non-admin. This non-admin has a type of non-admin, and this has a type of admin. Okay, so now here, this is let's say it's an admin user. Now what you will get is we are checking for admin user, so user is admin user. That's what I'm putting here. Now what I'll do is this type is admin now. So it's not admin or not admin. Since we are defining it as admin, we'll have the type properly allocated to this. So this is a simple example, but this can be very complex and you can use it anywhere. So for assertions, that is calculated in the compile time. So this function has not yet been run. We are not running the program or anything. But in the compile time itself, the types of compiler will run this and then define what the value would be, and based on it, the types will be assigned. So this is called type guards. So you can use it in either as an assertion. It will throw an error in a compile time also. That's one more thing, and you don't have to use if statement anywhere else. Or you can just return the boolean and then just use the is keyword without the assertion. Right. Next, we move on to conditionals. So this is a React example where we have the conditional props. So let's say I have a type here, which is a name and a size, and as a condition another prop. Here I have two different props here, two different structures here. One in one example, I have icon that is required. So here, so this is how to mention this. This is optional parameter. So whenever you give here, so let's go to the playground. So let's say age is optional for the user. Now, if I don't give age here, this will still work because the user is of type name is required. I haven't given the question mark here. Only for age, I have given question mark. So we can either give age or not. It doesn't matter. So it's an optional parameter. So here the icon is required. And
do we need default value for this particular options?
It doesn't matter. Even if you don't have default value, it doesn't matter.
No, I'm saying, can I set the default value if the user was not passed that value?
You can't specify here because it's just types here. You can specify here, let's say as a function parameter or something. So let's say this is optional.
For example, I want to set the age as a default age. Okay. So whenever the user was not passed the age value, it takes the default value.
That is, you can define it in the runtime. So you can't define it in the types. You can define it in the runtime only. So so here, if it's user is optional, you can define the types here. So you can define, so user is of type name, right? For any you can't do it. Let's say if it's a user. Parameter question mark as well. So let's say it's a string. Okay. So if you define this, then this will be optional. So it will already have the optional parameter here. So if you see the question mark, right? You see the question mark here, right? Near the user. So you don't have to manually specify the question mark here. You can just use the equal to. Then it will be automatically be optional. Then whatever you give here would be the initial parameter. So you can't define it here. You can define this in the type definition itself. But yeah, this is a way to define optional parameters. Now this would be age would be number or undefined. It's not defined. So that's what I'm doing here as well. So icon is mandatory, and the source can be optional. You can give never. So in TypeScript, if you give never, then this would be, you can either give undefined or never. But if you give never, it won't even be considered here. So undefined is actually a value, it can be ignored as well. But never is something we use to never assign a value to the variable itself. And here, the other property is icon is optional, but source is required. So what I'm doing is I'm combining these two properties here. So this is similar to extends keyword that I have used here. So we have a user, and I'm extending the another interface from the user. So now the admin user would have the type that is defined here, as well as the name that is coming from the user. So we're extending from the user. The same way, what I'm doing is I'm combining these two using the types. So I'm combining the common prop and the conditional props. So now the avatar prop would have name, size, and these conditions, either icon or source. So now so we have the avatar prop, and this is a React component. I'm having the prop as avatar props, and so in this props I will have these two icons. So this will have anything, the name as well and size. So while using this is how we use it. So if I do command control space, then I'll get what are the possible options here. So whatever it's not a question mark is required. So name is required. So I'll give name. So you can see here only the name is required. See, rest of everything is optional, but still I'll get the error here because name is not assembled to instant property. So source is missing. It will say source is missing because of the order here. Here, whatever it's in the end, that would take precedence. So it says source is missing. But if I change the order here, right? I change this to this. Now I have the source is required here and icon is required here. So now it will say icon is optional. Icon is required. So this doesn't matter. The source or icon. So either one you have to give. So now I give icon. Let's say icon is a component. Now it won't throw any errors. So it won't give source as an option. So you can't even give the source here. If you give source, it will throw an error because either you can give icon or you can give source. That's the beauty of it. So if you just use this, right? So if you just have this and have it as both as optional, now you won't get this issue. Now even this would work, but in our case it should not work. Either icon should work, icon should be required, or source should be required. So for that use case, you have to use the conditional props. And this is TypeScript docs. So you have to use / and then *. What it does is it will have the comments in your while you are using the IntelliSense. So if you see here in the right hand side, icon is required. So whatever we give here, right, that will be shown here. Same thing for source. Source is required. So whatever the comment that you give here would be useful, would be shown in the autocomplete from your editor. So that's what this comments is used for. This is called TS docs. So yeah, so basically, conditional props are useful when you want to have one a condition inside a property, inside a type itself. So either you can have the icon property or source property or source property icon. Either one is required. So for those things, you will use the condition prop. So this is for you use a pipe operator for this. Let's add the source back. So this is one concept.
Operating, we can provide a source and icon as well as like that, or
so icon is either one. So whatever you give here. So let's say here it's both is required, no? Now it will be both is required. You have to give icon and source. Okay, yeah. So yeah, so condition is either one. So if you can't give both, so whatever is never here, right? So since it's a never, then it's throwing error here. So let's say if it's a JSX, the error won't be there. But there's no so even if you do this, it doesn't matter, right? Then you can ignore this. There's no use for this property in this code itself. So basically, when you want to have two options, when you want to have two options, either you can have the source or so. Since it's avatar component, think of it as so either the avatar your image can come from an icon or from an URL source. So for that we are using this. So there are specific uses for it. So another example would be, one thing I can think of is colors, right? So color can be or size of the icon. So even this size. So if it can be optional, or in certain cases it can be required. So if you can give a size pixel or width, let's say size is a pixel one or width is a number that you can give. So either or. You can't give both. There is no use in giving both. So for those things you can use this condition properties.
What the value is.
Yeah.
So we used an ampersand operator, right? The
Yeah.
union,
Union.
both the types. So if you have common types between them, will it take which one will take precedence?
You can't have common types. So I think it would throw an error. So let's try that also. Type user equal to this. And let's say user equal to, let's say age would be string here. And let's say a third type, main user is user and another user. Let's see what the type is. It is allowing, but let's see what the type is. User. So I have another user. I have a user here.
There's a common div. Equal.
Sorry. Yeah. So here, what is the age? So age is never, see. So age, here the age property here. Can you see this? Age is never. So Typescript doesn't know. Since it's here, it's a number, and here it's a string, but you're combining both. So it can't take any precedence over. So it is defaulting to the never. So never is what I call as default, right? So it's defaulting to that. So it's up to the developer to structure the code in the same way that Typescript can understand. So if it is a number here, then that's fine. It will take it as a number. But if there's a mismatch, then Typescript can't decide what to take. So it defaults to never. Does it answer it?
Thanks.
Okay, anything else? Let's move on. So this is the main concept, generics. Suppose I'll explain what it is. So think of generics as a function. So you'll have this function that takes arguments. Let's say params, and it returns a value. So it takes a parameter and returns the value. Similar way, think of it as generics. Type. So this is how generic is defined. Here, let's say I have an item, and that is of type P. So this is like calling the generics. So if you define another type, you call string to it. This is how you call it. So now this item is string. So this is like a function definition here, and how you call a function is by the function name and then pass 20. Say this params is used here also. So here you're passing the function, calling the function with number 20, and you're getting what is passed here. So your parameter is being used inside the function. The same way, if you define generic here, this is like a parameter, and the parameters used inside the function. Like I'm assigning the type to this item, and this is being returned, let's say. Now what you get is, let's say this is the return value. Now what you get is, you're using this same way of calling this function name, and the type what you pass here. Just we have this angular bracket instead of this bracket. Now what we'll get is whatever is being returned from here. So now the item would be string. So if you pass the number here, now the item would be number. So this is generic. This is most powerful feature of TypeScript. So let's take an example to understand better. Let's take a React component. It's a list component. It renders a list of anything that you provide. So to type this, there is no way other than generics. So let's say I want a list, and I'll give what the list of items is, and I also give a function. I will render the item. The only use of this list component is to have all the CSS property, all the styles available to it. That's the only main use of list. What is the list that I want to render, that I will give from the calling component, from anywhere that I use the list component from. So now I'll define the type here, list props, and I'm taking this. This can be anything. So I have given us T. This is like a parameter name, so you can give any name here. So I have given us T item, and this props has items and render item. So items is a list of item. So that would be of type T item and array. So array of items. And in the render item, this is a function. This is how you type a function. So basically the parameter parenthesis and the item parameter name, and what is the type. Here the item would be the type of item is the item itself, and this would return a React component, JSX element. So now I'm defining a function here, and the same way how I have defined. So I want this component also to be generic. So now the type is generic. Now I'm defining the component as generic. So same way how you define the type as generic. Here this is a React component, and it takes the item, and so this is the property, right? So you can see this is the property. This is how you pass props in your React component. Define props in React component the same way we did here, right? You define the props as avatar props, and you get all the properties from the props. Same way I'm defining it as list props, but now I'm passing this I'm calling the defined type here. So whatever I'm passing it as list in the item, the same property, same type, I'm passing it here also. So this is I'm calling the type per se, similar to how I'm doing here. I'm calling same way how I'm calling the function. So now what it does is, this item would be of T item because we defined it here. This render item would be a function that takes an item and returns an element. So now the tricky part is when you use the function, you use the component here. What you initialize here would be available in your render item also. See, now I'm initialized with ID and name. Now the render item would have the same property, same structure, same definition here also. So now I get all the autocompletes here because item has an ID, item has a name. If I do age, right? Age is 20. And this is age. Now I get the property as ID and age. So now my list component is more generic. I can give any items to it, and I can show what to be rendered, how it rendered, what is the style of it. It can be common. It can be inside the list. So here all the CSS lies. Here we can have the list that's UL or LI. What is the style of it? Everything can be defined here. But this list is generic. I can render the list of anything now. So so that is based on the calling component. It is not tied to the list component. So that's how you define it. These items can be an array of anything. So this can't be anything. So this can't be a number. You can't do this because what it'll do is it is not of type. Number is not assignable to unknown array. So it is array because we define it as an array here. But this can be anything. So it can be a string array, it can be user array, it can be anything, any arrays. But it is an array. So you can generic is not anything. You can define what it is, but it's more extensible. So whatever you are not defined, say this is not defined, can be anything. So whatever is not defined can be assigned to the items here. So any questions? But what generic is, once you define a type, when you call it, you can call it with multiple types. It's like a function. So this is like a variable. This is like a variable, right? You define it once.
Like you don't tell what the type is at the time when you write the code. Runtime define what the type will be for that code.
Right, not the runtime also, but while you're developing. So consider runtime as while you're developing a new feature with the existing function. So let's say, so this is a variable. Think of it as a variable. This can be reused anywhere. So I'm using here, everywhere. Think of generic as a function. So see, this is a function. I'm calling this function anywhere, similar to a variable. I'm calling this function everywhere, but with whatever value that I pass. So I'm calling this generic with a number. I can call this generic with string also. Got it? Yeah.
I think what he's trying to say is you're trying to basically listen to the type when you're calling the component. When you call the component, you're trying to pass in the type that type.
Yeah, exactly.
That is what we're trying to do.
Yes.
It's not runtime actually,
Yeah.
because when you run it, there's no time support. When it's in the browser, there's no times. But
Basically, development time. Development time. Yes.
So basically, let's say he's the library author. Trying to use this component. He wants to say somehow, it should be generic. Whatever the user he can like pass many things, but he doesn't know what type user will pass it. So he's trying to say generally this is what is going to come. Okay. That is what he's trying to give that. But he's actually trying to give some constraints also, right? So if this item is this array of objects, the render prop should be this, only this constraint. Okay. There is a constraint also he's trying to give. So, but he's trying to be more generous for us. So anything we can give.
Instead, if he hasn't used generics there, then he has to have separate component for a list of strings, separate component for a list of numbers, separate component for objects and everything. Now he will have a single component that can accept an array of anything that returns a list of them.
So you're telling him beforehand itself what it would be, and then you allow that code to run based on that type.
Yeah.
Then you have the flexibility of calling the same type again, but you can still declare it to be a string or a boolean or something else.
Yeah.
And type will keep this.
Yeah. So basically, he's saying that it can be an array of objects. It can be an array of strings also. It can be, but if it's an array of strings, the whatever render box should be constrained to a string also. That is the constraint he is trying to put inside.
Yeah.
Right? That is beautiful.
Yeah. Because now it has a control is with the usage of it. So whatever you know what you will define here. The same way you know what you will use it for as well. So it doesn't have. So there won't be any mismatch here, because anyway you know what you will define as a type item here, and whatever you define as an item, that's what you can access from in the render item as well. So this would be another example that you can use for generics. So this is a simple state machine example. So state machine is just a list of states that you can go to. It can have an initial state, it can have an end state. So I don't know how to get into detail of state machines, but the example here is, so there is one key of property from TypeScript. So what it does is, let me show an example of it. Let's say type name user is already there. Let's say name string, age is a number. So if you do type of, let's say type. If you do type of user1, so it's key of something. The key of user1, what you'll get is, I have to use it somewhere. User keys. So you will get age and name, because that is the key of this type. So this is an object. User is an object. It has these two properties. You can call keys also as a property. So key of this user one is it can have either name or it can have age. Key of property. So the key of can be used in objects as well as in arrays. So in arrays you can use it as a runtime only. So const let's say string array equal to say blue, green, and we have to do as const also to make it as absolutely const. So now what you can do is of so you have to do type of, because this is a variable, it's not a type. This is a type, this is a variable. So first you have to change that variable to a type. So that's why I'm getting the type of here, and then I'm doing a key of. Now what you'll see is, okay, I think it has other things also, but you'll also get blue. Oh, okay, I think yeah. So type of key of type of will use it as a property here. So here the property is 0 index, right? That's the property here. So this is 0 and this is 1. So I think I messed it up, but key of is mostly useful in objects, but in arrays it can be useful for getting the index of the arrays. So for this example, let's stick with objects. So key of will get the property names of the object. So in state machines, that's what I'm defining. So config is can be type or interface, and just define it as interface. And this is the generic that I have. So this can be config of anything. So and the states would be the states type here, and the initial value of the state of the config would be key of the states. So what I mean by that is, so if I same thing, I'm defining a function here, and this is another way to use a function. I'm just using arrow functions here. Earlier we used a proper function keyword and then use a generic here. With this we have to, so this the difference is here. In case of functions we use the generic after the function name. There's no equal to here, but in case of arrow functions we use it after the equal to, before the parameter starts. Just use the generic here, and I'm passing that the generic to this function also as a config. Same thing, this is a function call for types, and this is the actual definition of the function itself. So now if I pass the parameter, right here, the parameter has initial value, initial and states. So let me try to do this. So if we control, you can take only two options, initial and states. So let's first define states. States can be an object, because so you can do one more also. State can be object, can be any object. Let's say a 25 b. And what another thing it will have is it should have initial value, and the initial value you will get autocomplete. So because the initial value is based on the keys of the states. So whatever I give here, let's say if I give C, any number, or it can be a string or anything. If I give C, then it will have C also. So state machines, basically what useful is for to controlling where the application state would be. So controlling where the application state would be. So it can't have meaningless state. So if you define 3 states, then the initial state should be end state should be either one of the three. It can't be anything. It can't be D, right? So you can't give D here. So to confine this, what you will do is you will define the states first, and the initial value should be based on what the states that you define. So here, the options that are available to you is these three only, because we have the states here. We have defined it here. So that's what this is, key of us. Same way how we had the render item here, whatever the item that you pass would be available in your parameter value here. So here, if I pass this ID and age, this would be ID and age. If I pass this ID also as number, this ID would be number, not a string. Same way, in your state machines, what I'm doing is I'm defining state as anything, but the initial should be a type of states. I mean, key of states. So my state can be anything, but it would be the initial would be a key of whatever I give here, A, B, or C. If you plus D, it won't throw in. It will throw in error. It can be only A, B, and C. So this is another powerful example for generics.
So since you have used key of the states can't be anything but an object. So it should be an object.
It should be an object, but I don't have that restriction here. So it should be, so let's say it is an array. Let's say it's an array. So it's an array, but
0 and 1.
it would be 0 and 1 and the other array properties. But to define that, you can do this. It should work. No. Okay, I think this would work. You can do extends here. Does it work? Let's say if I give something stupid throw error. No, I think array is also considered as objects. I think maybe you can do this. So just another way of doing it. We'll just do it and explain. Okay, state, I'm extending it as this. This is one way to confine it, but still it's going. But yeah, I think I'll try to come up with this offline after the talk. But we can restrict this also. So now the state can be anything, but using this, you can restrict it. For example, if it is a string, this string, I can only pass string here. Hence, I'm restricting this so restricting in the sense I'm saying this type would extend string. So it can be string or any string values. Same way I'm doing it here. So now I'm restricting it. So the states can be string only. So I can do it as for object also. And you know the syntax for it, because object also includes arrays. So array also works. But if you do this, I think other things won't work. It won't be a number or anything. So I think in JavaScript everything is an object, so it also allows this also. But yeah, I think I tried to find the syntax for it, but you can restrict it based on this here. So now state can be object or can be the thing that you define. Okay. Yeah. Let's quickly go over another example. This is really fun example. We have used useState, right, in React. So how it is defined, let's see. So this is how you use useState. So you will get useState and you can define your initial state, and you'll get the state as well as the setter. So how it is defined is like this only. So it will take a generic because it can be anything. State can be a number, state can be a string or anything, it can be an object. So it is a generic, and the initial state is the parameter here. So that is the type of it. And so this is how you define the return types in TypeScript. So it returns the type of what you pass, basically the state type, comma, the setter. Setter is this function. It will take in a new state and it returns nothing. So this set state would, how you call it? Set text, and it returns a string, right? So that's what it is. It takes in the new state. The type would be a state only, because whatever you set it would be the same type of setter also, and it does nothing. So it's void. So now this works. So this is how you do it. Sometimes, so now this would be string and this would be a setter. Same thing if you do a number here, 20. This will be a number. State will be number. So you can, the type safety is defined. So because of the generic, your type safety is defined. In your use state, you would also use this, right? You might have used this. You would ignore the initial parameter will be empty, but you will define the state will be string. So this should be string, and this should be, the setter also should be a string, but the initial value is empty. But this throws an error because it is required one argument, but you are not passing any argument. So for that, what you can do is you can just do this, and here if you return undefined, you can do this would work. So the string are undefined and setter is also string are undefined. This would work, but in actual React, what it does is, so if you remove this is working, but now if you pass a string here, this still is string or undefined. But we know it's not undefined because we are passing the initial value. Can never be undefined, but it's still string or undefined. But React does use another cool thing. I'll explain. Set is the equal to React dot useState. If you set this, it's a string, but in our case, it is still string or undefined. If you remove this and do the string, now it can be string or undefined because we are undefining it. We are not setting the initial value. But in this case, it should be string, right? But we got string or undefined. So to solve this, what React does is, React uses this overload concept. So you may have seen it, this is called function overloading. So in this case, the function takes a single argument. But in this case, the function takes empty argument also. So this is optional. So what it's doing is, so here I'm defining use state, takes same thing, t, initial value is required, parameter is required, and I'm returning the t and then the setter. But here, the same thing, but t is undefined, can be undefined. And here this initial set is optional also. Same thing, I'm returning t or undefined and the setter. Now, while implementing, I don't have to do this. I have to do this also. Since it's overloaded, if you give the initial parameter value, it fallbacks to this definition. This definition will be ignored. But if you ignore this, and if you just give this definition will be ignored. Only this definition will take place. Okay, because it's optional, we don't give the parameter, and this definition works, and we get undefined or string. But if we pass it, this definition is ignored, so we don't get undefined, we get a string. This definition is like commented out. It's not even used in TypeScript. But if you pass this without the initial value, now this definition is ignored. This would take place. String undefined. Okay. So that's how React uses it. I think I'm running out of time, but what I'll do is I'll show you how I found this. So you can just press this command and then command or control and then press this. This will take you to the type definition of the React. Now if you see here, so they are using dispatch and other things, using that, just using the same common type. So here, if you can see the same thing. They are doing the same thing, and then also yes or undefined. But in the bottom, in the top, they are setting the initial value also. See? So the same way, if I same way, what you're doing is you're setting the state as initial state as yes. So this is optional. So they won't even have the parameter value here, but I had this as optional. Where is it? Both are same, but this is how you can explore more types. So if you have found a library or is using it, if you want to explore how they are doing it, how they are using the types effectively, then you can hover over this and go to this definition and then see how the types are being declared, and you can learn from it and use it in your code base also. So I got few other examples, but since I'm running out of time, I'll just stop as well. Okay.
Yeah.
Okay, thank you.